Hello friends, welcome to Susan and John MathTube. In the last video, we learned how to reduce matrices into normal form. And with the help of normal form, we learned how to predict the rank. We even discussed about the row transformations, the column transformations, and how they are connected with equation solving techniques. So, in today's video, we will be making this method more perfect by working out two more numericals. We'll start with a 4x4 matrix, and I hope you're all ready with pen and paper. So let's start. So please copy the question. Find the rank of the matrix. Yeah, I'll give you a few seconds. So it's a 4x4 matrix 1 2 1 2 1 3 2 2. I hope you watched the last video and you know the procedure to reduce matrices into normal form. In case you have not watched the last video, pause this right now and watch how to reduce matrices into normal form. Okay, now let's start. So the first thing to do is make the corner element 1. It's already 1. Now the second thing to do is convert all the elements below 1 into zeros. You have to convert all the elements below that 1 into zeros. Okay, that is exactly what I'm going to do now. Anyway, I'll give my matrix a name. So I'm going to write let A is equal to the given matrix. And just beneath it, I'm going to write the operations. And as I told you in the last video, the matrices are not equal but equivalent. And the operations are, look at this. I want this character to disappear. And I have to use this one. So I can see very clearly 1 minus 1 into 1 will be 0. So I'm going to write R2 changes to, because this 1 is in the second row. R2 minus R1, because 1 minus 1 will give me 0. But the whole row should change. Now I'll focus here and this one. So it's obvious R3 changes to R3 minus. So 2 minus 2 into 1. My logic is very simple. 2 minus 2 into 1. That will give me 0 over here. But we cannot change one single element. The whole row should change. So we write R3 minus 2R1. And finally, so again the same logic, R4 changes to R4 minus 3R1. Okay, so look at this. The second row is going to change, the third one is going to change, and the fourth one is going to change. But there will be no change in the first row. So I'm going to write 1, 2, 1, 2 over here. Now R2 minus R1. So the entire row minus this. So 1 minus 1 and 3 minus 2, 2 minus 1, 2 minus 2. And then the operation is different now. R3 minus 2 times R1. So 2 minus 2 is going to give me 0. And 4 minus, yeah, that will be 0. And 3 minus 2, that is 1. And then 0. Now we have to subtract 3 times this row. So 0 and then 1. 4 minus 3 is 1. 6 minus 6, that is 0. Okay. So the next thing to do is we have to create zeros on this side of 1. And I hope you remember, if you want to create 0 beneath 1, below 1, then you have to do row operation. And if you want to create 0 on this side of 1, then you have to do column operation. Now what we do is, we have to change the elements on this side of 1 into 0. And what we do is, we use column operation. So you have to think in this manner. We have to think column wise. Okay. So the target element is 2, and I'm going to make it 0 with the help of this one. So the operation will be C2 changes to C2 minus 2C1, C3 changes to C3 minus C1, and C4 changes to C4 minus 2C1. Let's fill these things in column order. So I'm going to get 1, 0, 0, 0, and then this part. This will be 0, 1, 0, 1, and 1, 1, 1, 0. Okay, actually the trick is, once you do the row operation, just write these operations. Because when you do all these row operations, all these quantities will be 0 and this will be 1. So definitely these numbers will become 0 once you perform the column operation. And there will be no change for these numbers. Okay, now the next thing to do is, we have to create 1 diagonally. And the good news is, it is already 1. So all we have to do is, we have to convert all the elements beneath 1 into zeros. And again we have a good news, this element is already 0. So I'll write equivalent, and now I'll go for the operation. Once more I'll tell you, now we will not be worried about the first row or the first column. Now we move diagonally and it's already 1. If it is not 1, we have to create 1 by multiplying by the reciprocal of the number which is here. Now convert all the elements beneath this 1 into 0. This is already 0. So we are bothered only about this one. So this is my target and I have to use this one. So my target is in the 4th row. So R4 changes to R4 minus R2. So 1, 0, 0, 0, because only the 4th row will change. So you can be confident and write the first, the second, the third, and now you have to operate. So 0 minus 0, definitely 0. 1 minus 1, that is how we designed the operation. 1 minus 1, again 0. And 0 minus 0, again 0. So the next thing to do is, we have created 1, 0, 0, 0 towards the side 0, 0, 0. Now diagonally 1 and all the members beneath them are 0. Now we have to make all the elements to this side to zeros. So this is my target, and I told you, now we have to think column wise, and the operation will be C3, because my target lies in the 3rd column. C3 changes to C3 minus C2. So I'll write the first column, I'll write the second column, and the last column as such, because only the 3rd column will change. Now 0 minus 0 is 0, 1 minus 1, 1 minus 0, and 0 minus 0. Well, that's it. We are already at the last step. Okay, now look at this. All I see is an identity matrix. I hope you're able to see the identity matrix, and I'm going to write like this just for design's sake. So the order of the identity matrix is 3. So I'll write I3, and I'll put a few zeros to show that all the other members are zeros. And now I'm write rank of, I gave my matrix a name in the beginning, is equal to 3. That's it. That's it, my friends. Now let's try one more question. And these questions are from your past year's question papers. Okay, so please try the next question. Find the rank of the matrix. Okay, it's a huge one. There are 5 rows and 4 columns. Okay, so the first thing to do is to make the corner element 1. But the good news is it is already equal to 1. So all we have to do is we have to make all the elements beneath 1 into zeros. So let's write the operation, and I'm supposed to give it a name. Let A be equal to this matrix. And I told you these matrices are not equal but equivalent. Now I'll circle my target elements. This one, 5, 5, 4. And everything will be changed into 0 using this 1. Okay, so I'll write the operations. R2 changes to R2 minus 3R1, and then R3 changes to R3 minus 5R1, R4 changes to R4 minus 5R1, and R5 changes to R5 minus 4R1. So the second row, third, fourth and fifth are going to change. So the only row which is not going to change is the first row. Okay, now there is change in the second row. We have to subtract this and 3 times this. So 3 minus 3, that will be 0. Minus 2 minus 3 times 0, that is minus 2. And 1 minus will be plus, that will be 16. And minus 16. I'll strongly recommend you do the calculations by yourself. And always remember, even a simple mistake will give you the wrong answer. Even if you simply write plus instead of minus or minus instead of plus, that's it. One element will be wrong and your rank will be wrong. And the next row, that is 0 minus 28, that will be 5 times, and again 5 times. So 0 minus 2, and that will be 16, and minus 16. You can use a calculator if you want. 16 minus 16. So now you tell me what to do next. Exactly, we have to convert all the elements to this side of 1 into zeros. And whenever you do this, you're supposed to do column operation. So never forget, if you want to make the numbers on this side of 1 to the right side of 1 into zeros, you have to do column operation. Anyway, this is already 0, so our target elements are minus 5 and 6. So I'm going to write my target element is in the third column. So C3 changes to C3 plus 5C1. And then C4 changes to C4 minus 6C1. And one more very important thing, whenever you perform column operations, make sure you fill the matrix column wise. So let's start. 1 0 0 0 0. There will be no change here. Minus 2 minus 2 minus 2. Okay, now it's going to change, and we get minus 5 plus 5, that will be 0, and I told you there will be no change. The last one is again 0, minus 16, minus 28. Okay. Now tell me, what should we do next? The next thing to do is you have to move diagonally. Unlike in the last question, it's not 1. So we have to convert this into 1. And that's really easy. All you have to do is you multiply this row or this column throughout by the reciprocal. The reciprocal is 1 by minus 2. You multiply either this row or this column throughout by 1 by minus 2. Anyway, I will stick to row operation. R2 changes to R2 into 1 by minus 2. So the second row is going to change, and the first row will be 1 0 0 0, and second row will change. It will become 1 and it becomes minus 8, and the last one becomes 8, and there will be no other change. So what we do next is we have to make all these numbers into zeros. So I'll write the operations. R3, my target elements are in the third row, the fourth row, and the fifth row. So R3 changes to R3 plus 2 R2, and R4 changes to R4 plus 2 R2, and R5 changes to R5 plus 2 R2. Now let's fill row wise. So there is no change in the first and the second row. So it will be minus 8 and then 8. Now it's going to change, and the values are 0 and then 0, 26 minus 16, that will be 10, and minus 28 plus 16, that will be minus 12, and then that's just double, so it's going to be 0 0 0 and 0 0 0 0. Okay, now look at this. Initially we made this element 1, and all the elements below this 1 are zeros, and all the elements to the right side of 1 are zeros. Then diagonally we created 1, and now all the elements below that 1 are 0. Now in the next step we have to make all the elements to the right side of this 1 to zeros. And as I told you before, whenever you convert elements to the right side of 1 into 0, we will be using column operations. And my target elements are minus 8 and 8, and they are in the third column and the fourth column. So the operation will be C3 changes to C3 plus 8 C2, because our 1 lies in C2, and C4 changes to C4 minus 8 C2. So the third column and the fourth column will change, so there will be no change in the first column. So I'm going to write 0 0 and 0 1 0 0 0, and now it's going to change. So the values are 0 and then of course 0 and no change, 0 0 and again 0 0, minus 12 and 0 and 0. So we are almost near the normal form. You can see 1 and zeros and zeros, and again 1 zeros and zeros. Now we have to again move diagonally, and we have to create 1 over here. So there are two options. You multiply by 1 by 10 the third column, or you multiply by 1 by 10 the third row. Anyway, this time I'll prefer to multiply by column. So I'm going to write C3 changes to C3 into 1 by 10. So I'll fill column wise. So there is no change in the first column and no change in the second column, but the third column will be 1, because 10 into 1 by 10 will be 1, and no change in the fourth column. Look at this. So all we have to do is we have to convert this element into 0. Look at this. 1, all are zeros beneath, on the side 1 beneath, and side 1 beneath 0. Now we have to convert this. So I'll write the column operation. C4, my target element is in the fourth column. C4 plus 12 C3. So 1 0 0 0 0 0 1 0 0 0, and so I know it's going to be minus 12 plus 12. Okay, that's it. So we ended up with this form, and of course this is our normal form. Now take a look at this. I hope you're able to see the identity matrix. So I'm going to write I3, because the order of the identity matrix is 3 by 3. And then we write zeros over here. And now I can conclude rank of A, because initially I called it A, is equal to 3. So I hope you have a clear idea how to reduce matrices into normal form. And once you reduce the matrix into normal form, we'll be able to write the rank of the matrix. In the next video, we'll be discussing another method which will be more efficient. That's called the echelon form. So till then,